Your Next.js app crashes every 30 minutes with a JavaScript heap out-of-memory error. The culprit? AI-generated components with massive inline SVGs and deeply nested JSX that choke the V8 compiler during SSR. Let's break down Generate Shadcn components faster AI, how it works, and the exact mistake behind that failure. AI-assisted Shadcn generation is a workflow where you describe a component in plain English, and an AI model outputs production-ready code that uses Shadcn/UI conventions. You then install dependencies with the Shadcn CLI. Think of Shadcn components as Lego bricks and AI as a machine that reads your blueprint and spits out the exact bricks you need. First, initialize Shadcn in your project with npx Shadcn UI at latest init. Then, add a button component. Always run the add command before generating AI code so dependencies are installed and imports resolve. Run these commands in your terminal. The init command sets up your config and add installs the component. Then you can import button and use it. Your AI prompt should reference the correct import path. The quality of AI-generated components depends entirely on your prompt. Use a structured template that includes the component name, props, variants, and default styling. Always instruct the AI to use forwardRef and the CN utility. Here's a concrete example. This prompt asks for a card component with 3 variants and specific styling. The AI will output a complete component that follows Shadcn conventions. Generating one component at a time is slow. Instead, create a JSON spec listing all components you need, then feed it to an AI model with a system prompt. Use a script to parse the output and write each component to its own file. This script sends a batch prompt to the AI, splits the response by component markers, and writes each component to its own file. You can generate 50 components in one go. To match your brand, inject design tokens via the prompt. Use CSS variables or Tailwind classes. This ensures all generated components use your theme consistently. By including CSS variables in your prompt, the AI generates components that use BG primary instead of hard-coded colors. This makes theming easy. Always run a test suite on AI-generated components. Render each component with different props, check for console errors, and verify accessibility with Axscore. Automate this with a script. This test suite checks rendering, variant classes, and ref forwarding. Don't skip testing because AI generated it. I've seen a missing key prop cause a full-page re-render. AI struggles with polymorphic components that render as different HTML elements. You must explicitly specify the as prop in your prompt. Use class variance authority to manage variants. This is a production-ready polymorphic button using class variance authority and slot from Radix UI. It renders as a button by default or as a different element when aschild is true. AI is great for simple components like buttons and cards, but for complex components like data tables with sorting and filtering, AI often generates buggy code with infinite loops. Use Shadcn's built-in examples instead. For complex tables, use Shadcn's data table component built on TanStack table. It's battle-tested and handles sorting, filtering, and pagination correctly. This is the same issue we highlighted at the start. Here's exactly why that happened. A batch of 50 AI-generated components looked perfect in Storybook and compiled clean. But the AI model matched visual structure and Tailwind classes closely while silently dropping accessibility attributes that weren't visually obvious. Nobody diff-reviewed 50 components against an A11Y checklist before merging. AI-generated components often omit forwardRef and the CN utility import, causing runtime errors. The fix ensures the component uses forwardRef and imports CN from @lib/utils. The fix is to run every batch-generated component through an automated accessibility linter in CI before merge. Use npx slint plugin JSXA 11y with the recommended rule set. Also diff generated output against a known good component for the same pattern. This catches missing aria-labels and keyboard handlers. This is the exact issue from the incident. The AI generated a button without aria-label or keyboard handlers. Always run A11Y linting after batch generation. AI may generate duplicate components or miss some if the prompt is too long. Always validate the output count matches your spec. AI often forgets to import CN or forwardRef. If CN is missing, you'll get a runtime error. Always check imports after generation. AI-generated components can have massive inline SVG strings and deeply nested JSX, causing the V8 compiler to choke during SSR. Always extract SVGs to separate files and limit component depth. Add this command to your CI pipeline. It will fail the PR if any generated component drops aria attributes or keyboard handling. The article uses npx Shadcn UI at latest, which corresponds to Shadcn/UI v0. In v1, 2024+, the CLI is npx Shadcn at latest, and the component path changes from @components/UI/button to @components/UI/button. Same, but the init command is npx Shadcn at latest init. Ensure your AI prompts reference the correct import paths for your version. The article mentions accessibility issues, but doesn't show a concrete CI check. Add this GitHub Actions step to enforce JSXA11Y rules on generated components, preventing missing aria attributes from shipping. The article's production incident about 4 GB containers highlights that AI-generated components often produce deeply nested JSX and inline SVGs, causing V8 heap exhaustion during SSR. Mitigate by setting a maximum JSX depth in your prompt, e.g., max nesting 3 levels, and extracting static SVGs to separate files. Here's a debugging guide for common issues. If styles are missing, check the CN import. For build errors, run the Shadcn add command. For runtime errors, grep for the variant definition. Let's run through some common interview questions. How does AI handle ref forwarding? AI often forgets forwardRef, causing undefined refs. When to use AI versus handcode? AI for simple components, handcode for complex stateful ones. How to mitigate missing key props? Include key in prompt and run lint rules. And a few frequently asked questions. How to generate a Shadcn component with AI? Use structured prompt with name, props, variants, and styling. AI versus hand-coded components. AI is faster but may have bugs. Hand code for reliability. How to ensure consistent styling. Inject design tokens in prompt via CSS variables or Tailwind classes. Let's recap the key takeaways. AI generates components 50x faster. Always review for missing imports and ref forwarding. Use structured prompts for production-ready code. For complex components, use Shadcn examples. Ready to go deeper? Up next, Introduction to JavaScript, then variables in JavaScript, then data types in JavaScript, and operators in JavaScript. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.